Greetings, math fans. All right, so this is day 6 of chapter 7B, and I basically have 4 different application problems to do with you guys. Okay, these are the kind of problems you're going to see on a quiz and test, final exam, etc. So let's get started here. All right. First question says find the length of the 2 diagonals of the parallelogram. So I'm going to actually draw the two. I'm going to do one color here. So we're going to do this guy right here. And then we'll do another color here. We'll do blue. And we'll do the other diagonal here. Okay, not super straight, but that's what it is. Okay. Just remember your properties of parallelograms. And basically, it's all about triangles, guys. This is all about triangles. All right. So I drew these figures here. I'm going to do, let me change the color back to black again here. All right, and then we're going to add a couple different measurements. Do you guys agree this is 110 degrees right over here? So remember, consecutive angles of a parallelogram are supplementary. This is super important for this one. Okay, so that's 110 degrees. That means the other one's got to be 70 degrees. Pretty simple. All right, and let's just kind of label everything. Opposite sides of parallelogram are equal. So this is 15 centimeters and this is 9 centimeters. Now this is really pretty easy once you have all this, because let's just take a look at this one triangle right here. Okay, this guy right here. Okay, and basically I'm using law of cosines for this, because if you think about it, I have side, angle, side. So if I would quickly sketch this picture here. Okay, and I'm just going to draw that, what I just highlighted, that triangle. So I have 9 and I have 15 and I have this angle between 70 degrees. I can figure out, we'll call this x. Okay, I can figure out that, that diagonal. It's pretty easy. Okay, so we're just going to do x squared equals 9 squared plus 15 squared minus 2 times 9 times 15 times cosine. Don't forget, law of cosines, use cosine. Cosine is 70 degrees. Okay, and so we're going to get, if you do your calculation in your calculator correctly, please just type it all in your calculator. That's all you need to do. And you get x squared equals 213.7. So we take the square root, x comes out to be 14.6 because we're asking around to the nearest tenth. Okay, so it's centimeters. All right, pretty easy. The next one, of course, we'll just call that one y. And let me highlight in a little bit different color here. Let's highlight in green. Okay, so this one is going to be this guy right here. All right, so just a little bit different triangle, but no big deal. Again, this is going to be right here, side, angle, side. Okay, so let me sketch that picture here. So here's the triangle. And it's going to be 110 degrees and 15 and 9. So almost everything's the same except for, instead of cosine of 70, it's going to be cosine of 110. So you can actually just use, if you hit second enter on your calculator, you can bring up what you've already typed in. Second enter, it brings, actually, I think you have to hit it a couple times. Second enter, and it brings back a couple times before, and you can then just change the 70 here to 110. All right. So let me just write it out here. So x squared equals 9 squared plus 15 squared minus 2 times 9 times 15 cosine of 110. So you put that in your calculator. I guess we call it a y. Okay, so we'll call it y. So y squared is equal to 398.3. Take the square root, y comes out to be 20.0 centimeters. Okay, pretty easy. Find the 2 diagonals of the parallelogram. That's all it is. Okay, that's cool. Let's move on to the next one here. Did this problem, this is in December of 2021. So this is my second period class with Ashley and Gavin. Okay, so Ashley and Gavin want to pull Mr. Curvis into the pool. It's brutal. Ashley pulls on Mr. Curvis's left arm with a force of 120 pounds, and Gavin pulls on his right arm with a force of 140 pounds. The angle between Ashley and Gavin is 30 degrees. How much force does Mr. Curvis need to pull against the student so he doesn't get dragged into the pool? So again, it's a pretty easy setup, and we're going to use the parallelogram method for this. So if I have to set this thing up, let's set it up. It's going to be, we're going to have one here, and we'll make that Gavin and Ashley just a little bit less, just to kind of make a little more scale. So Ashley's pulling on a force of 120 pounds. So this is going to be 120, and Gavin's going to pull with a force of 140 pounds. Okay, and what we're going to do is we're going to make and the angle between them is 30 degrees. So this is 30 degrees. All right, so what we're going to do is we're going to make a parallelogram. And I'm going to actually change this color to red. And this is what I'm looking for, guys. I'm looking for the resultant vector. That's all. So this guy here, right here. Okay. So it's really not a big deal. Again, it's just using parallelograms. And think about it. If this is, let me change the colors here again. Okay, so if that's 30 degrees, remember consecutive angles of a parallelogram are supplementary. So this is going to be 150 degrees here. Right, that angle right there. And that 120 is 120 also here. So there you go, guys. There's your triangle. It's all about triangles, guys. So this is 140, this is 120, and this is 150 degrees. And you're looking for X. That's the red resultant. Okay, so that's how much force I'm going to have to pull against those guys not to go into the pool. And again, this is pretty easy. It's just law of cosines. So 1x squared equals 140 squared plus 120 squared minus 2 times 140, 120 cosine of 150 degrees. So x squared is 63,098. Take the square root of both sides, so x comes out to be 251.2 pounds, which kind of makes sense. There's only a 30-degree angle between them. That means most of that force is actually combined. So like if it was tug of war and Ashley and Gavin were one behind the other, I would have to pull exactly 260 pounds. But because they're only 30 degrees apart, it's pretty close, but not quite 260. It's about 9 pounds less. So it's 251.2 pounds. Okay. So that's pretty easy. All right, let's move on here. Okay, a force of 180 pounds makes an angle of 50 degrees with the second force. Okay. The resultant of the two forces makes an angle of 20 degrees with the first force. So this is that 180 pounds is our first force. So I'm just going to kind of sketch this out. And we have a 180-pound force. Okay. It makes a 50-degree angle with the second force. So here's the second force. So this is 50 degrees. So I'm going to call this the first force. And this is the second force. Okay. The resultant of the two, so right away I'm going to draw a parallelogram here, guys. It's a horrible parallelogram, but that's okay. Not the best in the world, but that's okay. Okay, so here is the resultant. Okay, so that's 50 degrees the whole way. The resultant of two forces makes an angle of 20 degrees with the first force. So this is 20 degrees right here. That's 20 degrees. Okay. So that is all the information that's given. So the deal is they ask you to find the magnitudes of the second force and the resultant force. So what I'm going to do is the parallelogram, remember you got to look for triangle, guys. So this is the triangle I'm going to draw right here. I'm going to draw that triangle. Okay, so I'm going to draw it right here. All right. Let's look at what we have here. Do you guys agree that this angle here is 50 degrees? That's consecutive angle of a parallelogram. So that's going to be 130 degrees. Okay, cool. That's 180 pounds. And so that means this is 180 pounds right here. So this is 180. Okay, so that's good. Do you guys agree if that is if this is 20 degrees right here? That's 20, and the whole thing's 50. Do you agree this angle right here is going to be 50 minus 20, which is 30? So that's 30 degrees. Perfect. That's all we really need here now. Because if that's 30 and that's 130, do you guys agree that's 160? So this is going to be 20 degrees. That's beautiful. So I'm going to call the second force X. I will call this Y. I think I had it in my notes. So this is Y. That's your second force. So Y. And your resultant force, which is just this line right here, right? That is, I'll call that X. Okay, we have enough information. We're not going to use law of cosines. Law of cosines is side angle side. I have only one side. Guys, I have a side angle relationship, right? I have a side angle relationship here. So that is going to be one of my law of sines. So it's basically 180 divided by sine of 30. Let's find X first. So it's just going to be X over sine of 130. Okay, you cross multiply, and X comes out to be 275.8 pounds. And that's my resultant force. Okay, and then the other one, I'm still going to use that 180 over sine of 30. Okay, but then I'm looking for Y, and so the Y is across from the 20, so it's going to be Y over sine of 20. Cross multiply, and we get Y is equal to 123.1 pounds. Okay, and that again, that is our second force. Okay, so that's it. Pretty easy. The only thing I have to say about this one, guys, is you got to be careful of making sure you're getting the right forces, right? The resultant is the line in the middle, and the second force is just the one above it. I mean, it's not a big deal. Just be careful setting it up, and it's really not difficult. Okay. Last problem here. Matthew and Sydney. Good old Matthew and Sydney. Matthew and Sydney take their pet yachts for a walk. Isn't that nice? They leave Conant and travel 25 miles on a bearing. Boop, boop, boop. Remember, bearing, very important. 25 miles on a bearing of 140 degrees. So remember, as soon as you see the word bearing, man, you got to draw a bearing line. Okay, so let's start out here with bearing line. All right, so here we go. There's a bearing line. All right, and it's 25 miles on a bearing of 140. Well, 90 is right to the right, so 140 is like this. So that is 140 degrees. Okay, and they're traveling 25 miles. Okay. An ixoi, very scary. An ixoi scares them, and they turn and walk 70 kilometers on a bearing 290. So again, another bearing line, guys. Here's another bearing line, and they're walking 290. So 290 is right. This way is if it's straight to the right, that's 90. Straight down is 180. Straight to the left is 270. So 290 is like this. All right, and that's 70. So it's a lot more. If that's 25, that's going to be 70. It's a little bit more. Okay, so there's 70. And that's 290 degrees. So let me draw that in there. 290 degrees. That's a hot day. Wow. All right, Dana. Good old Dana. Dana wants to bring them some tacos after this scary walk. So she meets them at the end of their walk. Find the distance Dan had to walk to meet Matthew and Sydney at the end of their walk. So she's at Conant, okay? I'm not trying to be tricky here. So this is really what I'm looking for. If I draw this, I'm looking for this. Because Dan is at Conant. I'm looking for that distance here. So I can tell you one thing, math fans. This is what's given. You're given this. Try to do my highlighter here. It's not highlighting. There you go. You're given this 25 and you're given that 70. I'm telling you, man, you know what you're looking for? You are looking for that angle in between. Okay, so you're somehow looking for that angle right there. It's going to be a side angle side, guys. It's going to be a lot of cosines. You can't figure out anything about, I don't really care about those other angles. Okay, I don't care about this angle or I don't care about this angle. All right, I only care about that first one that I drew. All right, so a couple things I can do is, if that's 290 degrees, well, here, before I even use that one, let's change colors here. Let's do blue. Okay. So if this is 140, do you guys agree? That angle there is 40 degrees, right? Because it's 180 degrees total. 180 minus 140 is 40. So if that's 40, do you guys agree that alternate interior angles? That's 40 degrees as well. All right, and if that's 290, do you guys agree the whole thing is 360? Let me change colors again here. Okay, do you guys agree this whole thing is 360? So this angle right here, it's basically 360 minus 290, okay, which is 70 degrees. So that green line that I just drew is 70 degrees. And if that part is 40 degrees, then what I'm looking for, which will make that purple, this part right here, that's going to be 70 minus 40, okay, which is 30 degrees. Okay, super important. So here's your picture now. Well, I guess we'll do it all in purple. Okay, so this is 70, this is 25, and this is 30 degrees. So what do we do in here, guys? Definitely law of cosines. So it's x squared equals 70 squared plus 25 squared minus 2 times 70 times 25 cosine of 30 degrees. A little messy, but x squared comes out to be 2/2493.9. So take the square root of both sides. So x comes out to be 49.9 miles. Okay. So that's how far Dana had to walk to meet Matthew and Sydney and give them some food. All right, some tacos, yes. All right, so not difficult. Most of these problems, you're going to draw two bearing lines. Somebody's going to walk someplace, and they're going to say, oh, and now we're going to change directions. They're going to walk another place. You got to look for alternate interior angles. You got to look for supplementary angles. You got to look for angles. You know, in this case here, we had to subtract from 360. You're always going to use both angles. I'm just going to tell you that. So both angles that I give you, and of course, both sides, because you got two distances that you went. Okay, and this is going to be a side angle side problem. Okay, look for it. And it means that angle's somehow between, in this case here, that angle, as I highlighted already, that angle is between the two sides. Got to look for that. Okay, so that's it. That is 4 examples. You're going to see these 4 examples on the quiz and test and on the final exam. So make sure you know what you're doing, all right? That's it, my fans. Have an outstanding day. Adios. Goodbye.